It pumped water out of flooded coal mines using nothing but steam and atmospheric pressure. And without it, the Industrial Revolution never starts. The Newcomen atmospheric engine was built by English ironmonger Thomas Newcomb in 1712, the first practical steam-powered machine in human history. Not elegant, not efficient, but it worked when nothing else did. Coal mines across England were flooding faster than workers could bail them out by hand. Entire operations were shutting down. The energy source powering early industry was drowning in its own excavation. Newcomen's engine injected steam into a cylinder, then cooled it rapidly with cold water. The resulting vacuum pulled a piston down with atmospheric pressure. That piston drove a pump. Water came out. Mines stayed open. It consumed enormous amounts of coal to produce relatively little work. Efficiency was roughly 1%. But 1% was infinitely better than zero. Over 100 Newcomb engines were operating across Britain by 1733, each one keeping a mine alive that would otherwise be abandoned. And perhaps the most remarkable detail, Newcomen was not a scientist or engineer. He was a hardware merchant who solved the problem no academic could crack. The machine that saved coal. And coal saved everything else. James Watt didn't invent the steam engine. He took an existing one and made it 4 times more powerful using the same amount of fuel. That single improvement changed everything. The Newcomen engine wasted enormous energy reheating its cylinder after every single stroke. Watt noticed this in 1765 while repairing a model Newcomen engine at the University of Glasgow. He solved it in 4 years. His solution was a separate condenser. Steam cooled in an isolated chamber while the main cylinder stayed permanently hot. No wasted energy reheating. No wasted time waiting. Efficiency jumped from 1% to over 4%. That sounds small. It wasn't. It meant factories could now run on steam instead of water wheels. Location became irrelevant. Industry could be built anywhere. He also invented the concept of horsepower to help customers understand his engine's output compared to the draft horses it replaced. That unit of measurement is still used worldwide today. And perhaps the most powerful detail, Watt's engine didn't just improve industry, it physically relocated it. Cities grew where factories chose to build. One improvement, one measurement, one new world, one machine, one operator, 8 spindles running simultaneously. It didn't just speed up textile production, it made an entire workforce obsolete overnight. The spinning jenny was invented by James Hargreaves in 1764 in Lancashire, England, a self-educated weaver and carpenter who solved the bottleneck strangling Britain's textile industry with a device he reportedly named after his daughter. Before the jenny, one spinner operated one spindle. Demand for thread was outpacing human capacity entirely. Weavers sat idle waiting for thread that never arrived fast enough. Hargreaves' machine allowed a single worker to spin 8 threads simultaneously using one wheel and one hand motion. Later versions expanded to 80 spindles. Same operator, same effort, 80 times the output. Textile production costs collapsed. Cloth became affordable for ordinary people for the first time in history. An industry transformed in years rather than generations. Local spinners who feared unemployment broke into Hargreaves' home and destroyed his machines. He relocated and patented the design in 1770. He died in 1778 without significant wealth despite revolutionizing an entire global industry. And perhaps the most striking detail, Hargreaves never received royalties from the hundreds of illegal copies operating across Britain during his lifetime. The man who multiplied human productivity and died nearly forgotten. It produced threads so strong that for the first time in history, Britain could make pure cotton fabric without importing a single fiber from India. One machine ended a century of dependency. The water frame was invented by Richard Arkwright in 1769. A former barber and wig maker with no formal engineering training who built the machine that created the modern factory system. Previous spinning machines produced threads strong enough for weft, but too weak for warp. Fabric still required linen reinforcement. Arkwright's water-powered rollers drew fibers out under precise tension, producing consistently strong cotton thread for the first time. The machine required more power than human hands could provide. Arkwright mounted it beside rivers, using water wheels to drive the mechanism continuously. Production never stopped, day or night. This single requirement changed everything. Machines needed rivers. Rivers weren't in cities. Workers had to move to the machines. The factory town was born. Arkwright opened Cromford Mill in 1771. The world's first true factory. Hundreds of workers, Continuous production, rigid schedules, modern industrial labor began exactly here. He became one of Britain's wealthiest men and was knighted in 1786. And perhaps the most remarkable detail, Arkwright stole significant portions of his design from rival inventor Thomas Hayes and spent years in court defending patents he may not have deserved. The factory system built on borrowed ideas. Just like most revolutions, it automated the final step of textile production that every previous machine had ignored, and it put hundreds of thousands of skilled weavers out of work within a single generation. The power loom was invented by Edmund Cartwright in 1785. A clergyman and poet with zero mechanical background who attended a dinner party, heard someone claim a mechanical loom was impossible, and spent the next 4 years proving them wrong. Before the power loom, spinning machines like the Jenny and water frame had created a massive thread surplus. Weavers couldn't process it fast enough. The bottleneck had simply moved from spinning to weaving. Cartwright's machine automated the entire weaving sequence. Thread loading, shuttle movement, pattern repetition, everything a skilled human hand had done for centuries, now executed mechanically at continuous speed. Early versions were unreliable and difficult to operate. Cartwright refined the design repeatedly. By 1800, improved versions were running in factories across Lancashire, producing fabric at speeds no human could match. Skilled handloom weavers, previously among Britain's best-paid workers, watched their wages collapse within decades. Many joined the Luddite movement, destroying machines across northern England in organized protest. Cartwright died with minimal financial reward, despite his invention generating billions in industrial output. And perhaps the most ironic detail, the man who automated weaving was himself a master of words, not machines, a poet who silenced an entire profession. Rainy Crevendig Bute in Tony Champam de Bingend, raced against 3 competing locomotives in a public trial, and won so convincingly that the judges had nothing left to debate. Steam railway transport became inevitable that afternoon. The rocket was built by George Stephenson and his son Robert for the Rainhill trials of 1829, a public competition organized by the Liverpool and Manchester Railway to determine whether steam locomotives were reliable enough for commercial passenger service. 5 locomotives entered. The rocket completed the required distance at an average speed of 12 miles per hour. Then it ran alone and hit 30 miles per hour, faster than any land vehicle in human history at that moment. Its revolutionary multi-tube boiler generated steam far more efficiently than any previous design. Instead of one large flue, dozens of small tubes passed through the boiler water simultaneously. Surface area multiplied. Steam production exploded. The Liverpool and Manchester Railway opened in 1830 using rocket-based technology, the world's first intercity passenger railway. Within 20 years, Britain had over 6,000 miles of track. Travel time between cities collapsed from days to hours. Fresh food reached urban markets before spoiling. Industries relocated around railway lines. Geography stopped limiting commerce entirely. And perhaps the most powerful detail, George Stephenson was illiterate until age 18. He taught himself to read specifically to understand engineering drawings. The man who connected the world never read a book as a child. Machines that quietly rebuilt the world. Subscribe for more of history's most insane inventions.